Welcome to our webinar on seismic design to the NSCP 2015 using ProtaStructure. Just like to introduce myself. I'm Nigel Watts. I'm the Managing Director for Prota Software. I'm actually based out of Kuala Lumpur in Malaysia, but many of you may have met me over the past year as I've been traveling quite extensively back and forward to Manila as we have been gearing up on entering the market there. Obviously, I know that presently is a very difficult situation with lockdown, and I'd just like to share that we're all feeling for everybody out there. We are also all working at home at present, my team here, and as you can see from there, our development team all working and self-isolating, doing the right thing during this period. And what we thought we'd do while this is happening is just try and share some of our knowledge and experience with both the software and with design generally to our user base around the world. So this seminar or this webinar today is just to give you some insight into what we're up to, and also just to share some knowledge that you may not already know. So while we're all sitting at home and perhaps we're not so occupied at present, we thought we'd take the opportunity to be able to share with you. So what I'm going to cover today is a number of things. I'm going to just talk briefly about our organisation as a group, and then I'm going to go into the software and just talk about background of the software. But what I really want to show you today is a live demonstration of how the system works. And I am going to focus a little bit on our seismic capability, and I'm going to summarize that at the end. So there's a few sort of technical slides that I'll go through just to give you some background on all the different things that we do within the software to help you deliver projects. At the end, if you do have any questions as we go, please, there's a chat open, and you're welcome to drop some questions, and I'll be happy to answer those at the end as we go. So just talking a little bit about Prota. Prota's been around for nearly 35 years now. In fact, this year we're celebrating our 35th anniversary. And we're an interesting business because we're just not a software house. We're also part of a large engineering group that have specialised in both consultancy work, as well as research, as well as software development. And it was originally founded or set up in 1985 in Turkey, but the business has been growing quite substantially over recent years. It's got quite an interesting history. We started developing software in the early 90s. First commercial versions of our software, which is the current ProtaStructure system, was actually delivered back in 1992, and it's evolved tremendously over the years. Now, so currently as a business, we employ almost 400 people around the world, mainly engineers and architects, so we're very much a focused technical business. And we have partners in over 15 countries around the world and growing. And we're also heavily involved in doing research and development. So you may have seen us at the recent ASEP conferences where we've presented a number of technical papers. We take a keen interest in what's going on in the research world, and a number of our staff are active in research and development and have published globally. So as I mentioned, we are growing, and currently I'm actually in the process of setting up an office in Manila. Obviously that's just been curtailed for the time being, but we'll be establishing an office there later this year. But as a business, we've been growing globally, and we've also been engaging partners around the world to deliver the technology to increasingly aware and our user base. Now, the engineering side of our business is very important to what we do because we are also designing and delivering projects just like you. and we've got a history of getting involved with some very interesting, complex projects. And this has really helped shape the way in which we create and evolve the software. So recently we were involved with the new international airport in Istanbul. For those of you who have passed through Turkey or Istanbul recently on your way to Europe, this is one of the largest, this is the largest passenger terminal building in the world. It's quite a complex structure, a very tight time frame for delivery, and we were able to take advantage of the software on our own projects to deliver this. We've been involved in other interesting projects as well, a number of airports around the world, in fact over 20, and these are just some of the interesting projects that we've been engaged with. Cairo Airport, St. Petersburg, Pristina Airport, even the high-speed railway that goes from Ankara through to Istanbul. We've been involved with designing. It doesn't stop there. We also get involved with large educational facilities and using the software to develop those types of projects. This is the actual final built job. This is the largest campus in Istanbul. We also get involved with some quite sensitive or interesting buildings, so strategically critical buildings that have to be carefully designed. Things like data centers for telcos and the like have been part of the type of projects that we get involved with delivering. And this experience on these projects has helped shape the software into what it is now. So we are consulting engineers as well, and we have also take a keen interest, obviously, in software development, and the way it's evolved has also been very practical in its approach in terms of delivering to suit to you in practice. So what is ProtaStructure 2019, and how is that focused around the NSCP? Well, ProtaStructure is actually one solution, but it's a range of different tools. So I'm going to cover a little bit today ProtaStructure, ProtaDetails, and ProtaSteel, and I'll just give you some background on what we do with ProtaBIM. But the idea is with ProtaStructure is that we're creating a structural BIM design model, and this is a physical model that you can build using objects, and I'm going to work with in both 2D and 3D to create these objects. And then from that physical model, we will automate much of the design and detailing process. In fact, we'll go right from the roof right down to the foundations. Now, to help you create information from the physical model, we have ProtaDetails, which helps you detail out your concrete work, and ProtaSteel, which helps you both design your connections and produce your steelwork detailing. Now, because it's a physical model, we can easily share and communicate this with other platforms like Revit. Okay, so it's very seamless and easy to share information with other platforms. Maybe you're working with IFCs as well, ArchiCAD and the like. You'll be able to share seamlessly with those platforms as well. So I guess the clients quite like the product because it's very easy to use, but the key driver for this is it's helping them deliver projects a lot quicker than they can conventionally. Now I mentioned ProtaDetails, so once we've created the model, ProtaDetails will go to work and it will then create all the detailed drawings for you, and I'll show you this in action soon, as well as creating all your automated connection design and steel detailing within ProtaSteel. Now we also have very intelligent BIM links, as I mentioned, and you can share information with a range of different products. We have quite bespoke links with sharing with Revit, where you can take models back and forward. You can make changes as you go to the projects, and you can collaborate and coordinate with other team members, architects, owners, other people who are involved with the delivery of the project who may be wishing to coordinate projects through Revit. We have excellent communication with Revit platform. So enough of me perhaps giving you an intro. Let's dive into the software, and I'll take you through how this works. So I'm just going to minimize my screen, and I'm going to get in now and just start up ProtaStructure, and I'm going to show you how to develop a simple model in the software. And as I go, I'm going to touch on a number of the important aspects that you would need to consider with relation to earthquake engineering. So when you start the system for the first time, we have a what's new screen here. Sorry, we have a quick start guide that allows you to be up and running quickly. All of our help systems are online and they're complemented with videos. So if you're wanting to watch YouTube type videos, they're available to give you more insight into the software. We regularly update the software. In fact, this is Service Pack 7 from 2019 version, and that's all documented. Now, I'm just going to come and create a simple project here. Okay, we can give it a name. So let's just call this, say, Manila 2020, and hit OK. And when we start here, we have created different templates. Now, these templates follow typical design and detailing practices in different parts of the world. So you may be working in the Philippines, but perhaps you pick up a work overseas, or maybe you're doing a project out of Singapore or Europe. We have different templates here that you can grab which follow the typical way that people would design and detail projects within those countries. So what I can do here is just come and grab a template. I'm going to grab the Philippines ACI template with the NSCP 2015, and I can just pick that up and import that into the software, and all the typical design and detailing settings are then established here. Okay. Now when we move into the software here, we've got quite a simple modeling environment. Along the top here, you'll see there's different creation icons for grid lines, columns, walls, beams, and the like. And you move downstream into the analysis and design stages. Now you can start the process in different ways depending on the information that you have. So if you have an architectural drawing, you could import this. You can pull off grid lines. You can lay out things the way you'd like to see them. If you have physical information from, say, Revit, that could be brought in as well. If you have a big project, and we see some huge projects where people have towers and podiums, you can break the project into components, and different people within your team could tackle different parts of those projects. So maybe somebody's wanting to model the tower and somebody else is doing a podium. You could then model those independently, but then merge them and combine them into one model later on in the project. So all this is aimed at trying to save you a bit of time and help you with coordinating the startup. Now I'm going to just set up a simple model here. I'm going to key into basic grid lines here just to show you an arrangement. So we can key in our axes here. Okay, you can use axis generators, or you can just key them in singularly one at a time. Okay, you'll see that there's an axis set out here. You can control the labeling of all these as well at the end. These have properties, and you can see the properties here. Now you can work with these. If you want to make changes as you go, you can. So if I say I wanted to change this axis from being straight to, say, curved, we can just key in a chord length there, and I've created a curved grid line. If you've got other unusual set out, you can create literally whatever you like. So I can create whatever funny geometry the architect may have laid out, I can set out in here. Now we work with physical objects, so I'm going to come in and place a column. Now you can see the column sizes here. You can play with the size, so maybe I want to make a 500 by 300 column there, and I can just place that against that grid line. Okay. Now if you've got multiple columns, you can just box around to put those in quickly. Okay, you can easily orientate or reorientate things. So if I want to make the, maybe I want to orientate this along the curvature of those grids, I can just come and set those columns up. We have libraries of other types of objects that you may wish to work with. So different column, concrete shapes. You have steel libraries here. You can even model things like cold form, composite. You can even establish your own built-up sections in here. So you can just come and choose from the library as to what you would like to model within the project. So you can give it a size, so it's a 550 diameter column. We will calculate all the underlying engineering properties here. You can modify things like stiffnesses and so on in here as well if you want to individually. So I can then just come in and use that and maybe come in and place some additional columns here. Now I'm going to work with some core walls as well, and we can just place a core wall within the frame, okay, and draw some walls. Similarly with beams, you can place your beams here, and you can key in some properties here, okay, and you can then just come and box around to create. Now the interesting thing with this process is that as I'm going, and I'll just zoom in to show you, we're automatically labeling everything here. So everything's labeled and set out and you might just see or start to realize that this is starting to look a little bit like a key plan. So as I'm going around and developing this model, you can see that we're creating an arrangement here. Now, if I just want to box around to put things in quickly, I can. Okay, I can just come in and draw things through to suit. Okay, it's intelligent, so it knows that these members are already existing. So you can draw through. It's smart. It knows that they're there. There won't be any overlapping. And you can just use intelligent snap points to come in and create things quickly as you go. Now, if you have certain set out, you can, if you hit F2, you can type in the exact coordinate that you wish to create, and then it'll pick up handy points like quarter point, mid-span, that perpendicular point, and you can create that element. Now, you don't need to be too worried about how accurately you model, because you can adjust things to suit. So if I wanted to just slightly tweak the arrangement to suit the underlying architecture, I can move things around using my cursor keys just to reposition things. So for example, these columns here, I may wish to just slightly move them up just to align with the facade of the building here. So you can see there that it's starting to look like a key plan. At this point, I'm going to come and establish my slabs, and you can key in the thickness of the slab you want to create, and then you can come in and assign some loads. Now, we do have libraries where you can build up finishes and the like, you know, screed, marble, tiles, and so on to create your self-weight, or you can come in here and key this in. So I'll just key it in, and I'll just come in and create some slab loading there. Okay, now you can put in different loads here. You can just type them in. So maybe I've got a slightly lower live load, or maybe my live load's more. Okay, we can just come in and create these to suit the underlying loading. Okay. Now, before you get too far in the model, you can check things. So we have tools in here just to make the process of review easy. And I'm going to use the visual interrogation here, so I can see sort of what column section sizes I've employed in the model there, maybe what slab thicknesses I have. Perhaps I'm interested in what my superimposed dead loading is here. So you can see that this is color-coded, and this just makes it easy for you to check and review the project before you get too far. I've also shown the live loads there. So there's a range of different tools here that you can use just to do model review before you get to developing the model too far. Now, I'm going to, at this stage also, well, I've been working in plan at this point, so what I'm going to do is just flick to a 3D view, and I can place and create different views here. So you can see here that key plan is now a 3D model. Okay, so what we're actually doing is we're developing these plan views. We're creating the underlying 3D model in the software. Now you can work with this model to define other things. I may in here want to come in and put in things like brick wall loading, and you can come and pre-program maybe standard brick wall loads here. Okay, you can type in the height. Okay, and then that brick wall load's created on that member. Now these can easily be copied, so I can copy the beam wall load, and we can, maybe I want to choose just to copy the external members there. Okay, and then we just paste it. So it's a very simple procedure for coming and setting up those loads around the periphery there. Now you can work with. We're working with a physical model, so you can lay out other things within the model. Here I'm going to put in, say, an opening, and you can see physically that that opening's been created in the model. The beauty of this is it's not an analysis solution; it's a proper physical object. So if I got the position of that wrong, I can easily just pick it up and move it around to suit. Okay, if I have other things going on in the slab, you may have drops and the like that you wish to define. You can come in and easily create those within the model. So think of this as I'm going to be creating exactly what I might see for construction on site. Okay, there may be other things that we want to define on a slab. For example, you may have again, you may have a brick wall or something just sitting on the slab. Okay, and whatever you create here, you can physically see. So you can see what's going on within the model there. Okay. There may be some other interesting things I'd like to do. Perhaps in my particular building, I've also got some openings, and I want to add an opening into a shear wall. Maybe it's for a window or a door. Okay, then I could easily come in and establish that in there as well. So you can see quite quickly there, I've just created a simple model. Okay, and I've just quickly developed that plan view. Now, once we're at this point, we can come and insert some floors. So I'm going to make this building, say, 5 stories high. And I can then take that particular floor and we can generate this information up. So you can choose what you want to copy up here, okay? But once you've done this, you can then just come and self-generate this up. So you could just maybe copy up part of the building, and maybe just the columns or vertical elements. It depends on what you want to do here. So you can see very quickly there I've created those additional floors. Now these are all editable. You can work with these. So if you want to make changes as you go, perhaps I want to remove elements or change sizes, all this is adaptable within the model. It's very easy to adjust things to suit and to consider different options. Okay. Finally here, I'm going to just go to the roof, and I'm going to also create a little bit of steel work here just to show you how that's done. So in here you can come in, there's different steel section libraries, there's Japanese, there's American, there's a range of different profiles that you can choose from. So you can come and choose a profile that you might want to work with here. Okay, maybe you want to use a UC, for example, and you can just grab that from the library and then you can create that in the model. Okay, so I'm just working, you might just see here, I'm actually working in 3D to create this. I've laid out those columns there. At the same time, I might want to put in some trusses. So instead of me having to key in all the coordinates, we work with physical elements, as I mentioned, and we've got physical libraries here of different types of truss systems that you might want to use. So it could be maybe a truss like that. It could be perhaps it's curved, okay, or perhaps it's not, okay. Maybe you've got another type of truss that you want to use. You can play with all these coordinates here. So it's very simple, just to parameters here. So it's very simple just to come in and adapt things to suit what it is that you want to see. Okay. I might align that to the top chord. Okay, you can see it's done smart things like remove those end elements so it doesn't clash with maybe a column that I'm inserting it to. Now the members are grouped. You can come in and make changes here. So if you wanted to use tubular sections or maybe you wanted to use channels, all this you can just adapt to suit the particular project that you're working on. You can also provide splice positions if you want to later design the splice joints. So if I hit OK, that gets created. But what it also does is it makes it available for me to then copy and replicate that across the building. Okay, so I'm just coming and created some additional trusses there. Okay, I'm also going to at this point come in and create some beams. I'm going to use maybe I'm using UB, and you can just grab a section to start with. Okay, you can play with properties like fixity. So if I want to just pin the end of the member, I can just come pin it, and I can just click each end, and we will automatically break the members to create those elements. Okay. Now you might have noticed that we've got smart snap points, so you can model to different points very easily. I'm just going to model maybe the top. Oops, let me do that again. The top beam there, and connect those across. Okay, and I can just kind of snap to those points to create that. Okay. The last thing I'm going to do with this model is just to put in some of the roofing. You may wish to define purlins, and maybe you want to make use of these to help you with restraint. Okay, you can see here that we're actually proposing an arrangement for you. So if you just click on those two end bays, it will come in here and set these up for you. You can come and play with these. So you've got different sizes that you could employ in the model, shapes and sizes and so on can be used. Okay, you might see that I've defined sag rods there. I could turn these off if I don't want to have them. It's up to me. And you see a little preview of what you're going to create before you create it. You can also add additional loads to the roof if you wish to come in and define those. Okay. Now bracing systems. I'm going to brace this up, and in here you can see that I've come and created braces. So again, I can come and play with this. Maybe I want to use a tubular section for my brace, and we could come and choose something that we might want to might think is appropriate. Okay. Now there's different ways in which the braces can be set. You can see that these are crossing each other. I may want them to be connected at the middle, so they're divided. I can play with the position of all of these in and out. If we'd like to have different types of braces, perhaps it's a V brace or a K brace or just a simple diagonal, You can just use this to adapt it to suit your particular situation and what you're wanting to model. If you want to move a brace, for example, then you can just work with this to change it, okay? Now you can see the underlying analysis model has stayed where it is, but if I want that to adapt to that position, I can also make that adjustment as well, okay? So if I just hit OK, that gets created, and we can then we can work in different planes to set up bracing considerations. I'm just going to run around in the roof as well and come in and create those also. Okay, so just a couple more things and we'll be done. So I'm just going to put in the end base here, and the last thing I'm going to do in this model is just to put in some girts. So let's just assume we've got some girts. I might make these say 650. Okay, and I'm going to remove the sag rods and just place those. Now the important thing with what I've been doing with the model here, and you might just have started to cotton on, is that everything I'm doing here is physical. So the way that we set things out is exactly how it would look on site. If you can see the steelwork there, I've got the girts are sitting on the face of the column. The braces are in the plane of the column. I've got my purlins sitting on top of my truss. These are all adaptable. If I want to make changes and rotate things and move things, all of that can be done. But the idea here is that what you see is how this would be built on site. Now this is really important because this helps us then drive the design and the detailing processes here. So I'm now at this point in a position where I've created a simple model. I may at this point just want to come in and start to run the analysis and design. And before I do that, I'm just going to come into the stories, and I'm just going to talk a little bit about some things in here. Now I've actually got a model where I have a very flexible structure at the top, and I've got my concrete frame below. Now I may want to just not consider the flexible structure at the top as part of my irregularity checks. I know that this is going to cause extreme stiffness warnings. I may want to remove that. It's not removed from the analysis. The analysis is still considering everything in here. We can do things like that. We can also come in here and set up basement levels. You can come and define things just to suit the architecture. So if I want to call the ground floor ground, for example, and the top floor roof, you can just come and work with these to label things to match the project that you're working on. Now you can also work and create different live load participation factors here. So if I had a specific factor that I wanted to set up in here, I can just key this in. We do have global settings, which I'll come to as well. Okay. Now you can also come in and set up basement levels, and we do two-staged analysis for the basement, which I will get to. That can also be established in the model. Now, before I get into just running through the analysis, I'll just talk about another couple of things or tools that we do have within the software. If you are selecting, say, a wall, now we have different types of walls within the program. So it's just not general shear walls. We also have what we call basement walls. If a basement wall, if you were defining a basement wall, it will be automatically meshed. And once we create a basement wall, we then know that we then would proceed to look at doing a two-stage analysis for seismic. So this is where the basement mass would participate actually in the superstructure or the building above wouldn't. And then the second analysis where the building above participates but the basement doesn't. And you would automatically have different R factors for those situations, and you can consider those in one analysis run within the software. You might also notice that we've got retrofit walls in here as well. So if you're wanting to upgrade an existing structure, you can also come in and define infill shear walls and design those within the building. So if you have an existing structure, you could model this. You can place infill shear walls within the model, and then you could as a method for strengthening the building to suit the current codes of practice. You can also come and work with columns. So in columns, we have tools to be able to insert things like base isolators. So if you wanted to create a base isolator in the model, you can, and there's different types of isolation systems that you can set up. There's rubber bearing, friction pendulum, triple pendulum, and you can define different properties here. Okay. You could also, if you wish, come in and set up and use things like column jacketing. So there's different types of column jackets here, concrete and steel. So these are just additional things that you can create within the model to help you with handling different types of scenarios that you might face as you're doing seismic design. Other interesting things that we have in here is that we have tools that make it very flexible, so you're not really confined by geometry. So if I had say for example, a column section here, which may be a little bit different, okay, we can use things like polyline columns to create whatever type of profile we like. And we can automatically look at containing this, and there's tools within the software that can help you work with these arrangements to create a custom bar set out. So I could come in and work with multiple group bars, for example, if I want to add in additional bars along the edge there. Okay, all of these you can do within the software. So while we will automate the section of bars for regular sections, you're not constrained. And if you had other unusual sections, you can even have openings in here. You can model and look at designing those within the platform. Okay, so at this point, I'm now ready to look at moving into the analysis and design. And I'm going to, at this point, just talk a little bit about what we've done with the NSCP, as well as the process that we would go through as we're looking to design the structure. So in here, you can see the parameters. I'm using the American codes. I've got the NSCP here, so you can choose the NSCP. There is the UBC as well as IBC available here, and there are other seismic codes that you could look to depending on where you're designing the structure. But if I use the NSCP, it will then load seismic parameters, and this then follows the guidance that is available for the Philippines. So I'm going to choose a seismic zone, and essentially here I'm just stepping through the NSCP to choose different parameters. So typically in the Philippines, your seismic zone 4, okay, I can come in and choose the source type, okay, and I can also come and define other factors, near factors, source types, and so on. So there's guidance here based on the code, and this is just in the software, so if you're not sure, you can come and refer to this within the software. So you can step through this, look at different occupancy categories. Again, this follows guidance in the NSCP. I can also come and choose different frame systems. You can have different structural systems in X and Y. Okay, I'm going to use a dual system with special moment resisting frame, and then we will automatically automatically define the R factor and the overstrength factors that you may wish to use here. So I'm going to look at a composite steel and concrete centrically braced frame, and then it'll then adapt the curves to suit. Maybe I want to go back and use so we can just come in and choose that factor. Now you can also define redundancy factors here as well. Okay, this is where you may have a certain amount of redundancy, particularly if you're looking at basement structures as well, that can be defined here. I can also come in and choose my soil type. So if I choose, say, a more denser soil, you'll see that the seismic curve will adapt to suit this. Now we're just following the guidance from the NSCP. If you wish to key in your own parameters here, you can. Okay, all this is flexible. You can even import your own seismic spectra if you've done a site-specific study. These can be brought into the software here. Now, during the analysis, we will automatically apply the loading eccentrically, and dampening can be set. Okay, so typically for concrete that will be 5%, but you can set other values if you wish. Okay. Now you can also choose a number of modes that you wish to run. Where we have a lot of capabilities is in helping you automate irregularity checks, and there's a number of different checks that we do to satisfy the code. So one of the key ones is the torsional regularity checks in plan, and we will check to see that it meets code guidance. If you have excessive torsion within your building and plan, the code will normally penalise you, and you would need to then iterate the analysis. Well, what we will do with these checks is we will calculate what that penalty is, and then we will apply it, and we will automatically iterate the analysis to apply that. So while we're also identifying if there is torsion irregularity, we're also calculating the associated penalties and applying those to the model. There's also irregularity checks in elevation, so we're checking for weak story effects, big stiffness irregularities, non-uniform mass distribution. All these are checked, and we also check for in-plane discontinuity. So this is where we are seeing whether the slab is effectively able to transfer shear loads into the walls, in-plane shear into shear walls, to make sure that the system is able to, the low paths can be maintained. So all these types of checks we're actually doing automatically as part of the analysis and design process. We will also automatically scale base shear. So typically you'll calculate your equivalent static base shear. And if you are normally running an RSA analysis, at the end of this, you'll need to scale the results up. Okay, but normally it won't capture the full, depending on the number of modes that you run, it won't normally capture the full base shear, and you'll need to make an adjustment. We automatically do this for you. So we will calculate that, and we will apply that. If you don't want to apply it, of course, you can turn this off. Okay. We will check for mass participation. We'll also check that the minimum dimensions meet the code, so that you're not putting in elements that don't satisfy the code of practice. Other important checks that we do is for joint shear. We will check joint shear. We will make consideration for where you may have elements eccentrically framing into a column. We will adjust the widths of columns to suit the joint shear requirements. We will also look at whether the joint is confined or unconfined, and what I mean by that is if you have 4 beams framing into a joint, that will be considered to be confined, typically. Or if you had less than 4 beams, then it will be unconfined, and the associated checks will be different. So all these types of things we will check for you as part of the process. Now, obviously, a very important consideration for concrete design, build or capacity-based design is strong column weak beam checks, and we will automate these checks for you. We will look at this floor by floor in different directions, and we will calculate whether a floor in a given direction will satisfy the code. And typically you need to have at least 70% of the elements in each direction per floor satisfying the code, and we will perform those checks for you as we go through. Now, other checks that we're doing second order effects checks. If you have coupling beams, we are checking to make sure that the coupling beams interaction with coupling walls, shear walls, is satisfied the code. These will be also performed as part of the checks. So there's a lot of underlying checks that we're doing here, and I thought I'd just spend some time just to talk about those to explain to you what's actually being done automatically as we go. Okay. So if I hit OK, that's done. Now I'm going to come and set my load combinations up here, and I'm going to pick up the pace a little bit. So my gravity cases are here. This is my dead and live load. Pattern loading can be established. You can also set up stage construction analysis if you wish. I'm going to run response spectrum. I'm also going to run vertical earthquake if I want to. You can set up wind load and other load combinations here, but the idea is that in the software, these are all automated. So all the load combinations there are just automatically set up for you. If I hit OK, that's done. You can come and play with the material properties here. So grades of steel, rebar sizes that you may typically want to use can all be set up here. So you can just adapt this to suit a particular project that you're on, okay, and just customize this to suit availabilities. Now, I'm going to, we will calculate the crack section properties for you based on code. Perhaps what I did mention just then is that I can have gravity cases as being uncracked, and I can have lateral cases as cracked. And we will set up 2 separate stiffness matrices and run this in one analysis run. Okay, so these properties can be set here. Okay, we're following the code. If you want to make adjustments to these, you can. Now I'm going to use rigid zones in my model. This will introduce some economy. I can also come and mesh my core walls here. So I can choose the mesh. Slab models can be set here. Now we will automatically define rigid diaphragms. If you wish to come in and mesh particular floors in the model, you can, and you can then use flexible diaphragms. Okay, all of this can be done within the building. So you'll just come in and establish what it is that you'd like to see. Now the analysis is just a button, and what I'm going to do here is just go through and I've set the analysis. If I just hit go, it's now going to spring into action and move through and look at analysing and designing the structure. Now, prior to that, you can also do model checks. So we can automatically look at your model and interrogate it before we move into the analysis. And that process can pick up any silly modelling mistakes that you might have made. Any basic errors can be established, and you can go back and make adjustments before you move into running the analysis. Okay, so just give it a second. It's saving away, and then you'll see the analysis kick up, and we will move through and run the analysis. Now, this is a physical model, and what we're doing is we're automatically distributing the loading from the slabs and the beams, so from the slabs to the beams automatically. You might just see off to the right there, you might see that we're actually automatically creating yield line distributions. We can also create finite element distributions. But we're automatically building the analysis here, and it's going through and running this. We've streamlined this process, so you'll find that the analysis is quite fast, and we are moving through and performing the analysis, and then we will move into looking at the design. Now, as it's going through the analysis, it is doing a series of checks. It's checking to see that all those irregularities are satisfied. If they're not, then it will make adjustments to the results. And it will also perform a number of other, and it will advise you as it goes. So if you do have things that perhaps don't satisfy the code, then they'll be picked up and you'll be advised. So you can see here the analysis is done. Okay, I've got a couple of warnings here. I've got loading sitting on a slab, so I may want to use a decomposed FE loading, but it will pick up things. So you can see here I've got a little bit of irregularity in the structure. My torsional regularity is a little bit high. Okay, I might need to run another couple of modes to get the mass participation right, but the rest of the checks are there satisfying the code. Okay. So that's done. Now, it now then is moving straight into designing everything. So I'm now going to go in and design all my columns and beams. We will optimize the design for you. We will look at the most efficient design for a given arrangement of a given size and loading arrangements. We'll try and come up with the most efficient, economical approach for those elements. So you can see here it's just gone through and run all the columns and walls. All the different load cases and combinations are being checked for this. So we will merge all the combinations into an envelope, and we will design for that envelope as we go. So we're also running the beams at the moment, so you can see that they're going through and running. The other interesting thing that you can do is, I know you're probably all aware that on any project you'll have changes that occur, and we can during the process, if there are changes to the project, just change the model. You can simply change the model and maybe add some loading, maybe change some structural arrangements. We keep everything that you had done before, so all the steel and design is kept, and we can then perform check designs as we go. So there's a really nice way of being able to manage changes as they occur on site. We recognise that that's one of the challenges that you face with delivering any project. Okay, so you can take advantage of that feature as well. Okay, so just finishing off, it's done. Now post-analysis here, I'm going to have a look at the results. Now we will. So what I'm doing now is just going to open up the analysis model. Okay, and this is very much like you might see inside of, say, SAP or perhaps STAD. So you can see here my analysis wire. Okay, and I can come and look at different things within here. So I may be interested in seeing the axial loads. So you can see I'm looking at axial loads due to dead load there, but you've got different combinations here that you can review. Okay, so you can just look at those. You can see how the results are changing as you go up the columns there. If you want to filter out and look at a particular floor, maybe I just want to see the second story and I'm interested in looking at my shear or my bending, and maybe it's due to a particular seismic case, or I just want to look at a particular seismic combination, you can see these results here. Okay, so the important thing also about using the rigid zones, which I did, is that we can take the moments at the face and not centerline. So that can help drive a little bit of economy with the way in which we are performing the design. Okay? So I could also, at this point, maybe I'm also interested to look at the behavior of the structure. I might want to see how it's displacing under, say, my seismic loading. Okay, I can animate this so you can see the structural behavior there. This is under earthquake in the X direction with a positive eccentricity. We can also look at modal behavior, so you can look at your fundamental mode. As I mentioned, my building's a little bit eccentric. It's not perhaps ideal. When my first mode is a torsional mode. Okay, and you can see the period in the X and Y is shown, and you can look at higher modes here. So you can look at the dynamic behavior for different modes within the building, and you can see how that's behaving. Okay. So once you're happy with this, you can then move into look at the design. Okay, I've designed a number of elements in the building. You might see that there's one or two columns that haven't quite passed here. We can come in and interrogate these. Now, we have different ways of designing the columns, so we will use a fixed bar layout method, but you can try and push the software to design based on a maximization or a minimization method. So I could look at designing these in a iterative way. Okay, that hasn't quite satisfied the code there. I may need to look at resizing things, but the idea is that will go through. Okay, so let's design this section. What we can see here is that we're calculating automatically the neutral axis position, and we will work out the levers for these bars and calculating capacities. Okay, now there's a detailed design report that will cover how we're going about doing this, and you can also view this within the interaction plot. So you can see here we're creating a biaxial bending interaction plots here, and you can see where that critical combination may sit within that. So if I click OK, that's now it has designed. Okay, and we could come and look at the rest of these here. Now what we also will do is for shear walls we will do critical wall height checks. So if I just choose these, so for the shear walls we are actually designing based on an envelope, and we will look at the maximum moments at the base, and then we will formulate the envelope up the building. So we're not designing the walls based on the analysis results, we're designing these based on envelope. Okay, and the software will automatically take care of this. It will also identify critical wall height zones where we need to employ special ductile detailing in accordance with the code. So this will be done as part of the design and detailing process. Now, if I come out and maybe at this point I also want to look at the beam design, okay, we can just click on the members, and you can see that the beams have been designed here. We can just click on a particular member and we can look at this in more detail. Okay, so you can see here we've automatically selected the bars here. Okay, you can come and look at the envelopes that we're using for the design. So here you can see different load cases, so dead and live and the like, as well as earthquake, seismic, and we will then merge these and create the underlying combinations, as well as the underlying envelope diagram, which we will use for the design. Now, what we do for the design is that we will firstly apply the longitudinal bars. We will work out, based on what's actually provided, the moment capacities, and we will at each end of the beam, and then we will work out the shear design based on critical shear. So we will take the moment capacities divided by the length, and we will obtain the critical shear, and we will design our link arrangements here based on critical shear. Now that same process is carried out for the columns. Okay, so this is again another kind of specialist procedure that has to be done for the seismic design, and this will be automated within in the software. Okay, so I'm just going to touch on a couple more things before I get into looking at the documentation. I know we're getting up to the hour. I'm going to try and maybe we might just go over a little bit over 12 or try and wrap up by about 10 past 12. So here, I'm just going to come and select the foundations here. And if I right click, you have the option to insert pad bases or pile caps. I'm going to insert some pile caps here. Okay, and within here, we can set up the allowable loads and so on within this, and then we can design this. So it's a batch design process. I'm now moving in and designing all the foundations. They're done, and we can then group these. So we'll find those that are similar and automatically create your groups. So you can see just the click of the button there, I've created my pocket foundations. If I wish to over here, we could also come and insert, say, a pad base. Okay, and again, you can define parameters in here, allowable soil pressures and so on, and then we will calculate the base. You can have square bases or rectangular, and you can also make them slightly eccentric as well. So if things are not quite maybe a near boundary and the like, then you can adjust these to suit. So if you hit OK, then that foundation will be created. Okay? Now there are other foundation types within the software that you can easily establish. If you did want to include things like raft foundations, these can be set up in here. You can come and choose to put in a slab, okay, and then a raft can be defined. Now, I could use FE to design this, and we can do things like integral strips and punching shear checks to drive that. We can also come and define things like maybe in here I've actually end up with a piled raft. Maybe the soil conditions are not satisfactory, and we can then come and define these as well. Okay, so within the software, there's a lot of flexibility to be able to tackle different types of foundation arrangements. It's really up to you. You can also have combined footings, strip footings. A range of different foundation systems can be established in the software to suit. Now, one thing I didn't touch on, and I'm going to go back to it, is post-analysis. Once we have done the analysis in here, there are a number of reports that we create. Okay, and if I just click on the post-analysis check reports, the software will produce a report which follows the NSCP in terms of a range of different checks it's doing to satisfy the code. So I'm just going to open this up and show you. Okay, and you can see different checks as well as the different associated clauses that are being done. Okay, so you'll see here that things like stiffness or regularity checks are being done, and this is the relevant clause within the NSCP that's being followed for that check. Okay, we are checking things like interstory mass irregularity checks, and again, the clauses are shown. Torsional regularity checks cover 4.5.2 of the code, and again, these will be documented so you can see whether or not that's satisfied. I mentioned to you that the base shear is automatically scaled, okay, and you can see here the calculations around that, and again, this will be documented to the code. Okay, we will check mass participation checks. So I think I needed to run maybe another couple of modes to satisfy that. Again, we're checking that to the code. Okay, relative story drift checks are performed. Okay, as well as second order effects requirements checks. Okay, now if any of these aren't satisfied or there's penalties due, the software will calculate these for you. Okay, and then apply it again in the analysis. Another key check is slab wall in plane shear stress checks. This is where we're checking to see that the slabs can actually, acting as a diaphragm, actually transfer the shear forces into the walls. Okay. Basic information like story masses as well as story center of gravity are all reported here. Okay, and you've got quite comprehensive reporting that we're creating within the software to cover that. Now, another interesting check is the joint shear as well as the strong column weak beam checks. And I'm just snapping through this because it's trying to look at the roof, which is steel. Okay, and again, it will produce a report that covers both joint shear checks that need to be satisfied, as well as strong column weak beam behavior. Okay, so again, this will all be designed and reported within the software, which you can use to check. Okay, so just just show you this report, and then I think that's enough technical stuff, and we'll get into looking at the documentation. Just give it a second, it will open up, and I can show you the various checks that we're performing. Okay. So here we can see the strong column weak beam checks, and it will look at the floor by floor in different directions to see whether this satisfies the code. So you need to have at least 70% passing, okay, and the software will look at both directions to satisfy that. And you can see the joint arrangements here as well as the capacities that are being calculated. Okay. Now the other important checks that we do, and if I just come down a bit further, you'll see that we also are checking for joint shear, okay, and there's various checks that we're doing to satisfy the code here as well. And if something's not satisfied here, maybe I've got maybe a situation where I've got to increase a joint, then that will be also indicated here. Okay. Now, once we've completed our design and we're wanting to move to document, we then can move in to start looking at the we can start then moving in to look at other tools that we have. So I'm now going to move into Prota Details. So once I've done my design and I'm happy, I can then start to document the results out. Okay, and obviously the key delivery for you guys is creating the drawings. Okay, and I'm going to show you how Prota Details satisfies that. So it's just going to save the project here, and then it will load up Prota Details, and you'll be able to see how we go about doing that process. Okay. So you can it's just loading this up, okay, and Prota Details is a CAD system as well. You can happily draft in it, so you can use it to produce your drawings as well, okay. And in here, we're working in DWG format, but when you load this, what I'm going to do is just come in and automatically come and create my underlying documentation. So I can choose here what I want to draw. I'm going to insert these to my title block, so you can come in and just choose. This would be your typical title block that you can set up. You can give things naming conventions, so if you wanted to call things, say, a key plan, and maybe you want to call it key plan 1, you can just come and set this in here as well. Okay. There are other things that you can control, so you can control things like the scale of the details, maybe the way you want elements to be truncated. All this can be controlled within here. Now, at this point, I then just want to come and create. So simply in here, I just choose to draw, and the software will go away and start to work its magic. Okay, so it's now taking all that information that we have designed, and it's coming in now and automatically creating all the underlying drawings for us. Okay, and you can see that it's just moving through this process now. Okay, and ensuring that and optimizing the way that the things are placed within the drawing sheets, and trying to create everything for you in one go. Okay, so just give it a second here, and you'll just see that it's now starting to lay things out. So you might just see there that it's laid out the foundation plan. Okay, we will do things like dimension these up. There'll be set out dimensions placed against those. Okay, all laid into your drawing sheets. And if you just give it another few seconds, you'll see that it's finished. Okay, a couple more beams to add, and we'll be done. Okay, so if I just zoom out here, you'll see that we've created all the underlying drawings in one go. Okay, so all of these have been documented out based on our model set out and our design. Okay, and if I want to come in and look at those in more details, I can. So here I can see my polecat details. Okay, here I can see my key plans. It's very smart, so it understands, you know, the way that you typically draft. So in a slabs, a dotted, outer, a solid, that type of thing is done. All these layers and line types, and even the way that these are presented is adaptable, and there is a number of settings within the software to customize this to suit what you're wanting to achieve. Now this will be your title block, and you can lay them directly into your sheets, okay, from the software. You can produce different types of drawings. So if you want, say, set out drawings against grid, okay, you can. But also here you can see other details like our elevations. All these are drawn up here, okay, so for the shear walls and so on. Where you've got critical height zones, these will be calculated and detailed accordingly. And you can just see through here that I've created those. If you look at the columns there, again, you can see the detailing that's being performed for the columns. And we will look at containment detailing, and all of this will be included as part of this. Okay. If you come on down and look at there are other ways that information can be presented. You can present them in schedule. Okay, you can see there. There's that funny column that I created earlier. That's all been designed in detail as well. Okay, and you can also see your beams here. So again, you can see that we're working out the plastic hinge zones and detailing links in there accordingly. Okay, and you can see as I work across here the way in which the bars have been detailed out there. Now, if you do look at a bar, so you can see there's 3 diameter 25s. It's positional mark 7. We are quantifying all of this. So for the 7s, there's 25s. There's 9 of them altogether. We've got 90.45 meters in total, and we have the full quantities or tonnage takeoff for that drawing. So this includes everything, all the laps, the lengths, everything's being calculated here. Okay, and it's all intelligent objects. Now these are objects, as I mentioned, and you can come in and adapt these. So if I did want to change things, maybe I wanted to change a bar size and increase it. We're working with physical intelligent objects within the detailing, and these can be adapted to suit. Okay, so I've just gone and updated that bar. I've made that a 32, and you can see that my drawing now is adapted to make that a 32. At the same time, we're also recalculating the steel tonnages. So now I have 3,083 kilograms of steel, more than before. So this is dynamic, and you can come in here and interact with this and make changes to suit what you're wanting to produce. Okay. Now, as I mentioned, this is a CAD platform. Okay, you can work with things in here to adapt it to suit. So if I wanted to, say, pick up this detail and perhaps I want to move it, I can come and play with this. If I wanted to, maybe I want to, say, crop the section. Okay, I could just come in and cut that and move it down. Okay, and place it down below. You can see there's some smart tools with the way that we repeat labels and the like. So this has really been set up as a CAD system to suit structural engineers and detailers. Now you can produce things in a schedule. So if you want to see things documented in text, you don't need to provide all the drawings. You can present the information in this way if this is what you would like to show. Okay. Now there's other drawings in here. Obviously, I also designed my pad bases as well as my pile caps, and they're all documented here also. Now, Prota Details has other features within it. I won't go into these in detail. Just suffice to say that everything that we've designed here is available in the trees, and you can come and grab elements within the tree and redraw them. If I just wanted to grab, maybe I wanted to draw up an elevation of the entire column. Okay, we could come in and grab that and draw that up. Okay, you can also draw in here in detail. So if I wanted to create additional detailing as part of this, then maybe I want to add in some extra bars. This can all be done within here, and you can come and adapt this to suit. Okay, so there's tools in here that you can use that go beyond just automatically producing the drawings. You can use this to help you create different types of details on your projects. Now, if this was I can grab these, and you can use tools to help you quantify this. So if I wanted to take off all that rebar, then that can be done. Okay, there's just handy tools within the system to help in this area. Now, I won't touch on these today, but there's also a detailed design library where you can design other components within the project. So if you're wanting to design cantilever walls, or maybe a retrofit wall, or perhaps a single pile cap by itself, or piles, this can all be done within Prota Details. Okay, so that just summarizes Prota Details. We have automatically laid drawings into our sheets. We can work with these details. You can create details on the fly and happily draft them here. And we have these dedicated design and detail libraries that you can take advantage of. I still have most of you with me. So perhaps what I'll do at this time is I'm just going to, the last thing I'm going to touch on is ProtaSteel. And once we've done the steel design, we can send models to ProtaSteel, and we can then move to create our connection design and detailing. So I'm just going to show this to you very quickly, a couple of minutes, and then I'm going to move in and just summarize, and I think that will be enough. Okay. So I'm just opening up ProtaSteel here. What ProtaSteel does is takes all the loading and all the analysis results from ProtaStructure into ProtaSteel, and we can then move in here and start to look at different connections. So within ProtaSteel, there's a range of different macros here. And you can see I'm just panning across. So there's end plates, there's things like haunches, there's welded joints, there's gusset plates. There's a wide range of different connections, tubular connections, connections to concrete, and the like are all available in here. And the way it works is you can just come and grab a particular connection that you want to apply and click on the elements to connect them, and ProtaSteel will do its magic. So it's coming in and designing these. Okay, if I, maybe at the end where this column is connecting to the beam, I can come and create a connection here. Now underlying this, we're actually creating the underlying connection report. So we are producing all the underlying documentation to the chosen code of practice. And here I might want to create a design report for this particular connection here. Okay, and I'm loading this. So just bear with me, that's loaded into Word. And you can see the connection report here. So you can see the various checks that we're doing in accordance with the code. These are all clearly documented, so it's very much a little bit like you've written this out by hand. Okay, and we go through all the different various checks that are associated with satisfying the code for that connection. Okay, now almost all the connections are now designed within the system. Okay, so if you're doing haunches or bases or simple connections, these will all have associated design calculations with them. Now, obviously, if I had to go and click every single element within the project, that could be quite time consuming. So we've introduced new technology to help that process, automate that process. So if I want to, I'm going to use IntelliConnect, and I can choose to design different connections here. So you can choose to maybe have an angle pleat there. I can then just run that, and the system is just automating the connection design of all those elements within the model. So if I come in here, you can see now that I've then designed those purlin connections automatically. Similarly, I might want to come in and use IntelliConnect to do my girts. So again, you can choose your preference here and then just run it, and again it will go through and try and make those connections for you. So everything it's doing here is we're looking at both the design as well as the constructability. Now I'm going to choose this frame here, and I'm going to ask it to come in and connect the trusses. So I'm going to use a truss connection. We will size up the gusset plate, but you might just see it's just working its way across the truss here, trying to assign connections to those joints. Okay, so this is really intelligent. This came out of experience that we have with fabrication, and you can see that we're coming in and creating all detailed connections here to satisfy the code. Okay. Now, in areas where you can't get particular connections, we have other macros that can be used to drive this. So if I wanted to connect these elements here, okay, I can just use macro to create that. Okay, and you can see that that's set up here. Now these are macros, so you might just see that I've got a bit of a bolt hanging out the top there. Okay, you can come in and make adjustments to these on the fly. So if you want to drop things and make various adjustments to suit, you can. And if I just apply that, you can see that that's just I've just tweaked that to suit the type of connection that I might want to make there. Okay, entirely up to me. All this is very, very flexible. Now I'm at this point just going to quickly come and create some basic connection details in here. Okay, to do that we can create views of the joints, and I'm going to add some objects to these views. So I'm going to click these elements here, right click, and then you can see that I've created a box around these. Now you can control the views here. You can look at different views from different angles, okay, and you can set these up. So think of that like a camera, and I'm taking a different snapshots of that particular connection. Now the final thing I'll show you is that we can then use these to create views of this particular element. So I'm going to just cut across here. Okay, oops, let me do that again. Okay, we can just come and create an elevation of this truss. Okay, and that can be then placed into drawing sheets. So I'm going to call this maybe truss. Okay, and if I hit OK, this sheet will be created, and those views can be placed within the sheet. So you can see here I've got my view of this truss. I can move in here, and we can look at starting to look at dimensioning. So if I want to dimension the purlins here, okay, you can just come and annotate this to suit your particular project. So let me just finish that off. But what you'll also notice here is that's that view. There's that circle around that view that we created, and if I just hit this box, you'll see that the details for that view are now being prepared. Okay, now I can control the annotation here. You might just see that I've got my welds shown. Okay, we can come and turn those off, so I'll just turn those off so they're not indicated there. But what we can do is once we move in here is we can start to annotate this. So I'm going to annotate sections. I can annotate my bolts. Okay, and you can see that they're also being set up in here. Okay. Now I can just tidy this up. Maybe I want to add some extra dimensions in here. All this can be done within here, and you can create your engineering drawings very quickly from this model. Now, if there's any changes to the physical model, these details will automatically update. It's all seamless. Okay, everything will just adapt to suit any modifications that you make. Now, I've just been focusing on engineering drawings here. Okay, the system can also produce all shop drawings from the program. So you can look at assembly drawings and shop drawings, and it can actually break out, and you can look at various components. So if I wanted to, maybe I just to show you. Oops. Okay, so here you can see that's that component of that truss, and you can see all the various components that go into that, the bolt holes and so on, and we can then break these out into actual shop detailing and assembly drawings if that's what you need to do. Okay, so I think that's enough. I've talked quite a bit. I'm just going to quickly wrap up. Thank you for your patience. And I'm just going to go through just to summarize in the software. So I covered a range of different things that we're doing with Seismic. I talked about the site-specific spectra and following the NSCP and the way that these are set up. Okay, so this just follows step by step the NSCP. We automatically calculate all the mass for you. You can have different live load participation factors. We use a 3D eigenvalue analysis for calculating dominant modes and the like, which is then also used for things like base shear calculations. You've got equivalent static methodology. Irregularity penalties are automatically applied, and we use CQC for the moments of position. I mentioned that we automatically will scale the base shear. You can have different behavior factors into orthogonal directions. Okay, you can also input your redundancy factors there as well. Okay, and you can play and control with the stiffnesses. Okay, and that's you can have different crack properties for dead and live cases as well. Okay, so if your gravity cases you don't want to have cracked, but your lateral cases you do, you can easily do that in the software. Now, another key consideration of the seismic design is often you'll have basements, and these need to be treated differently. And we will do a two-stage analysis for the upper and lower structures, looking at different R factors for above and below, and automatically combining those for design. Okay. Other checks that we're doing: building base, building height checks, we are performing. So I looked at this earlier. There's a vertical earthquake that can be considered. You can't really make a mistake in the software. So if you do choose the wrong approach, the software will advise you. So it will look at things like building dimensions and make sure that you're choosing the appropriate methodology for designing the structure. I talked a little bit about the horizontal regularity checks that we're doing, as well as vertical regularity checks. So these are things like soft story, mass irregularity, weak stories. All these are checked in accordance with the code. We will check relative story drift, second order effects. Basic checks like overturning are all being done. I showed you the strong column, weak beam checks that have been performed, as well as the joint shear checks. Okay. Now, the ductile design and detailing for both the beams and columns, based on capacity shear, based on ductile code, ductile detailing requirements, is all being performed, and that includes detailed checks for containment. Now, the column design and detailing will all be done in accordance with the ductile detailing requirements. You might see in these, you can see different plastic hinge zones or containment detailing in critical shear zones are being provided. When columns change in size and the like, the bars will adapt. Okay, if you've got bars that need to curtail because a column steps in too far, this is all automated. So these are smart things that we're doing to help with the way in which the detailing is being done. Ductile design and detailing, including the critical height zones, okay, and designing the walls based on envelopes. Diaphragm modelling, you've got different ways of the diaphragms can be set up, rigid diaphragms, no diaphragms, flexible diaphragms. They're all available in the software. You can have multiple diaphragms. So if you've got towers, a couple of towers that are side by side, we will set up independent diaphragms. The software will automatically recognise this and run this in the analysis. Talked about basement walls, and you can set up the basement walls, and we will do the two-stage iterative analysis for that. You can also define things like coupling beams, isolators can be set up, and we can look at base isolation. Another thing that I haven't really touched on today is the assessment and retrofit of existing buildings. So this is really looking at performance-based design of both existing and new buildings. And we have different approaches for this. So you could be doing displacement-based or force-based, single, multimodal, or non-linear time history and pushover analysis can be performed. And based on the level of requirements that you're trying to satisfy, if it's a new building, there may be immediate occupancy categories that you're trying to satisfy. We can check that against the code. If you are looking at upgrading an existing building, then you can take advantage of what I showed earlier with employing things like infill RC shear walls and column jacketing to help you strengthen the building to maybe meet life occupancy stages. So these can all be done within the software. You don't have to, if you have an existing building that you're wanting to assess, you can just predetermine things like steel ratios, and the software can make a basic assessment of the structure based on limited information. So you can choose, you can start this process even if you don't have all the information available to you. Now, for nonlinear analysis, we have introduced integration directly with OpenSeas. Those of you are familiar, this is developed by the University of Berkeley, and we will automatically feed OpenSeas with the fiber, a nonlinear fiber model. So this will take account of all the concrete and steel properties, and we will use distributed plasticity to create that model. Now we will automatically feed OpenSeas. OpenSeas will then run, so whether you're doing nonlinear pushover or nonlinear time history, it will run. For pushover analysis, we will look at different performance plots. You can look at any individual node in terms of this, and we will create reports which will check to see whether this satisfies the level that your behaviour, whether it's immediate occupancy or life safety. Reports can be produced to see whether this meets those criteria. For nonlinear time history analysis, you can come in and choose different ground motions. So we have a library of different motions that you can choose from. Okay, we will automatically scale these for you. I know that if any of you have ever done this before, you'll realise that this is very quite challenging. So we will automatically scale them for you, and we will do all the post-processing and provide you with all the relevant reports for this. As I mentioned to you, the software is used extensively around the world. We've got some great clients that are using the products. These are just some snapshots of some product projects that we're doing, have been done across Asia. So in KL, the biggest shopping mall in KL was done within the Prota tools. Projects in other parts of Asia, in London. Okay, these are just some interesting projects in Hong Kong and the like that have been designed within the system. Okay, as well as other hospitals and so on. So it's a real broad mix of interesting types of projects that have been done within the software. Here in Malaysia, even the King's Palace was was used to design, but we used the software to design that building. So just to conclude, I think we're trying to provide exceptional value to our clients. That's why all the systems, it's a one single system. Everything that I've shown you today comes together. And I think the key focus is providing a complete solution to help you deliver your projects right from conceptual design right through to the documentation. So I hope you like what I covered today. We are continuing to invest significantly in the technology, and I haven't told you at all today, but we've got a really very, very exciting new release of the software coming in May, which is the 2020 version. And then we've been working very hard on that over the last 6 months, or last few years actually, to bring that to market. But what we're also doing to support engineers across the Philippines is that we are introducing the software at a very special offer. So if you are interested in the technology that you've seen today, we are offering this at half our normal price in other markets across Asia. So you have the opportunity to acquire the software at a significant discount. We've had many clients in the Philippines take this up. In fact, we've got a rapidly growing user base there, and it's great to see them starting to use the software, and we're starting to see many of their interesting project models coming through support with interesting questions that they've got as they get to familiarise themselves with the system. Now, this also includes training. Obviously, we're not able to provide direct training at this point in time, but we have online training resources, e-learning and the like that you can use to engage yourself with the software at this point. And our support team are working, and they're able to answer any technical questions that you have. So if you are interested in this at all, please drop me an email. My email address is there, nigelwatts@protasoftware.com, or you can get at us through the website. Also follow us. If you are using any of Facebook, LinkedIn, Instagram, Twitter, YouTube, you jump on there and follow us, and we'd love to hear from you and get your feedback. So just in wrap, I'd like to thank you very much for attending today. I appreciate you taking the time